test tomorrow. This was a pretty productive review last period. I think people really felt like they came out having things squared away. So, first things first, I'm not going to look at a lot of problems. I just want to look at good representative problems. Problems that like this one, if you can do this one, there's a lot of other ones that you're guaranteed to be able to do. I picked kind of the hard ones. So what I want you to think about on these, whenever they say solve the equation, before you jump into it, don't just immediately jump in and start doing stuff. Think about it for a second and think about what is it you really want to do. What's our strategy? So for a problem like this, how are we going to solve this? Okay, first of all, we want to get rid of those fractions, don't we? So we want to clear all the fractions by multiplying both sides through by 8, right? So if I do that, if I multiply both sides through by 8, same thing as 8 over 1, right? Now you can I recommend that you cancel first and then multiply, but you don't even have to do that. You could just multiply straight across and then reduce. So for example, if I multiply straight across 8 over 2, it's pretty easy. That's just 4, right? So I'm going to get a negative, first term is going to be a negative 4x squared. Next term, if I multiply straight across, I get negative 24 over 4 is negative 6. 4, if I cancel, 8 over 4 is 2 times negative 3 is negative 6 times x. And then here you really don't want to multiply that out, do you? Would you rather just cancel the 8s and just get 17? Right, so plus 17 equals 8 times 1 is 8, right? Okay, so now what? Say it again. Subtract 8? I mean, you could. Okay, but now I guess I want to know, what are you going to do with this? How are we going to solve this? We have two different options, really. Only one of them is going to work, though. Can I isolate x? Can't isolate x. I always want to, that's my first and best option if I can do it, but why can't I isolate x here? How come? Braxton, how come I can't isolate x? Yeah, good. I get two different kinds of x, an x squared and an x. They don't combine, so I'm stuck. I can't isolate x. So what do I have to, what's plan B? Quadratic formula. Okay, I don't know if did I want to hear that? I didn't hear it. So let's see. To use the quadratic formula, though, to apply the quadratic formula, we first have to put this into standard form. We have to write it as an equation in standard form, which really just means what? Set it equal to 0, but the other thing I need to have is it has to be equal to 0, and what has to be true of the number in front of x squared? It has to be positive, right? So in this case, which side would I probably just add all the terms to? The right side, okay? Or I could add them to the left and multiply by negative 1. Either way would work. All right, so if I add everything to the right side, I'm going to get 4x squared. I'm going to add 6x over there, and I'm going to subtract 17. So negative 17 plus 8 would be what? Negative 9. And then I'm going to have an equals 0 on the left, but let's put it on the right instead, right? So now all we have to do is just apply the quadratic formula. So what is the quadratic formula in this case? X equals negative 6. It could be negative b. Well, b is 6, right? So negative 6 plus or minus square root b squared. B is 6. So 6 squared minus 4 times a, which is, times c, which is negative 9. All divided by, whole thing, right, by 2a, so 8. Okay, so all we need to do then is just simplify that. This is where I think people probably have the most trouble, though, is simplifying the radicals. I understand, I mean, but people are getting better at it. I really feel like people are getting a lot better at that. So what are we going to get inside the radical? Let's see if we can turn this into a number. 6 squared is 36 minus 4 times 4 would be, so negative 16 times negative 9, what's the sign going to be? Positive. 16 times 9 is 144. So we're going to get the square root of 36 plus 144. And what is that? No? or minus the square root of 180, all divided by 8. So we got to simplify that radical, right? Now, remember what that means. That means we want to get as much of the number outside of the radical as we can. Our only way of doing that is to break it up into products of perfect squares and other numbers, right? So what is, and we don't even have to get the biggest perfect square. It's nice if we can, but we can do this in multiple steps if we need to, or if it works out that way. So let's just work on simplifying that radical. The square root of 180. What's a perfect square that divides into 180? 9 does, for sure, right? So we could break 180 up into 9 times what? 20. Square root of 9 is 3. Okay, so we get 3 times the square root of 20. But we have to always ask ourselves, could I go further? Is there a perfect square that divides into 20? 4 does, sure. So we could take the 20, the square root of 20, and break that up into the square root of 4 times the square root of 5. And what's the square root of 4? 2. But you can't forget that 3 that's out front. Still there. So I've got 3 from my first perfect square, 2 from my second perfect square, and the 5 gets stuck inside. 3 times 2 is 6, so I get 6 radical 5 is what this thing reduces to, right? So we could then rewrite this as -6, and we could even split this up into 2 fractions. I think that's easier. You don't have to, but I think it's easier. -6/8 plus or minus 6 times the square root of 5 over 8, and I can reduce those fractions. Right? What is 6/8 reduced to? Yeah, good. Okay, so we're going to get a -3 on top, 4 on the bottom, and same thing here, right? So we're getting 3 on the top, 4 on the bottom. So my final answer is just -3/4 plus or minus 3 times the square root of 5 over 4. That's it. I can put it all over a common denominator if I want to. I don't need to. Okay? Make sense?
Yeah.
Okay? If you can do that, you can do any of those. That's as hard as they get. Okay, what about this? Let's skip that one. That's just going to be one with an I in your answer, but we'll do more of those. What about this guy? What's my strategy here? Isolate x. Good. Good. I can isolate x because I can point to a single x. Therefore, I can isolate it. Good? Okay, no problem. So now, if we're going to isolate that x, what are the steps I follow when I'm isolating x? SADMAP. I'm going to reverse PEMDAS. Okay, so, and I urge you to do that. I mean, let's follow those directions. Now, do I want to try to distribute the 10? No. Do I want to try to square out the 2x plus 12? No, that's the opposite of what I want to do. What I want to do is take all this stuff and get rid of it, right? Not do stuff with it over here. I just want to get rid of it. So in order, what do I do then to get rid of that stuff? Add 4. Okay, if I do that. Minus 4, you're right. Just checking. You're good, you're paying attention. Excellent. Subtract 4. So those go away. We're going to get 10 times 2x plus 12 squared equals -1600?
Yep.
Okay, what's next?
Divide by 10.
Divide by 10. Right, make sense? Okay. Now, what happens if I divide a number with zeros at the end by 10? Right? So -160. Okay? Now what? Square root. So 2x plus 12 equals, before you even say the square root though, plus or minus, good, don't forget that. Most common place to make a mistake on a problem like this problem. So plus or minus square root of -160. Okay, so, okay, and there's an I there, isn't there? I'm gonna get, when I take the square root of this side, look, I've got that negative sign right there, right? And I take the square root to get rid of the squared sign. Negative number inside the radical becomes an I after the radical, right? And so I get square root of 160 times I. What's a perfect, obvious perfect square that divides into 160? Yeah, just 16 times 10, right? So we can break this up into the square root of 16, which is 4, times the square root of 10, times I, right? We good?
Yep.
Okay. So then, if 2x plus 12 equals that, what are the last two steps? Okay, subtract 12 from both sides. Where does the negative 12 go? Good. Divide everything by 2. And let's split that up. So I get negative 12 over 2 plus or minus 4 radical 10 over 2 times I. I can reduce those. It's the first fraction reduced to. What about over here?
2 times 30.
Yeah, it becomes a 2 over 1. So I just get 2 times the square root of 10 times I. So both of those answers, right? Enter them separately with comma. Okay? We good? All right. Okay, this one we won't even do. This one is an easy one though. What do the directions say here that makes it so easy? Much easier. Yeah, it's decimals, first of all. I don't have to have exact solutions, so I could use a calculator. And I'm only looking for real solutions. So if I don't get real solutions, what do I enter? N, right. So all I have to do on this one, this is really simple. I just have to put it into standard form. So push everything to the left. So A is 3, B is negative 6, C is 1. Plug them into the quadratic formula. On your calculator, it equals, get an answer. How can I check all of my answers on this? Anytime you ever have a question that says solve, how do you always check? Plug it in, right? So when I get decimal answers for this, all I have to do is take those decimals, and to make it easier, maybe put them in parentheses if you want, but put those decimals in for x in this original equation, or even in this equation, and just see if it works. Okay, they should work. Now, you might, because you're using decimals, that you're going to round maybe, you might get back an answer, instead of getting back, for example, 0, you might get 0.0015, but that's just because of the decimal errors, right? If you get something close to 0, you did it right, okay? And we're going to get 2 answers there, one for the plus, one for the minus in the quadratic formula, okay? Good. All right, what about this? This is an absolute freebie. These are easiest question on the test, by far. There's maybe one other one that's like this, it's even easier. But these are the 2 absolute freebies. When it asks for the modulus like this, just read these carefully. It's not asking for z, it's asking for the modulus of z, right? So there's the complex number z. What's the formula for a modulus? Square root of a squared plus b squared. Good, so what the modulus of z means is just the modulus of a plus bi, which is always just the square root of a, what's that be? A squared plus b squared. What are the coordinates of this point? You gotta, this graph is tricky. Read it carefully. So if I follow that one down, it's between the 2 and the 4, right? It's going by 2s. There's 1, 2, 3. So it's at 3. The x coordinate or a coordinate is 3. And then over here, it looks like it's at 9, isn't it? Right? Everybody see that? There's 8, there's 9, there's 7, right? So it's at 3, 9. And so the complex number would be 3 plus 9i. What's a and what's b? 3 is a, 9 is b. So the answer is just the square root of 3 squared plus 9 squared. So square root of, what is that? 81 plus 9, so 90. Square root of 90. wants the exact answer, I could simplify that a little bit. What's a perfect square that goes into 90? 9. So I could make it square root of 9, which is 3, times square root of 10. Okay, good? We're done? That one won't go any further, will it? Okay, because there's no perfect square that goes into 10. Okay? All right. Okay, moving on. The second review and second test. This stuff isn't too bad. I mean, really, if you can just kind of organize your thinking about this, there's not a whole lot going on here that's really difficult. There's a couple of these. Probably the other one that might be worth going through on these would be the completing the square one. But there's not a lot happening here on this. I think this is an easier test. People had a harder time with this review, but I just think they hadn't had as much practice with it or something. So what about these? There's some questions where they're going to ask you to write the quadratic function in either a specific form, or let's just pretend that they all ask for general form. So we get to practice with that, because that's probably what I'll ask you on the test. But remember, when we do problems like this, where we're trying to be given some information and turn that into a quadratic function, our goal is, if we're given points, coordinates of points, we always want to, if possible, use one of the special forms, because they're so much easier. So if you can use vertex form or factored form, definitely go for it. It's going to make the whole problem a lot easier, because you get lots of information that's given to you. This one fits which form, obviously? Vertex form, because we're given a vertex. It tells us the vertex and a second point are shown. So there's the vertex, there's a second point. So what is vertex form? Okay, so all we have to do, even if I want to put this into general form, all I really need to be able to do is plug in the values for A and H and K in vertex form, and once those are numbers, how could I put that into general form? You just simplify it, just multiply it out, FOIL it out, distribute A all the way through, add K to the, just kind of expand and simplify, and that's it. Then it ends up in general form. But to get there, we first have to start off fitting this stuff to vertex form. So what are H and K? There's the vertex. What are the coordinates?
1.
So H is 1, K is 2. So if we plug those in, y equals A times x minus 1 quantity squared plus 2. How do I get A? Plug in the other point, good. So if we plug in the coordinates of the other point, that's x equals 3, y equals 4. So we get 4 equals A times 3 minus 1 squared plus 2. Okay, what's 3 minus 1?
2.
Squared.
4.
What's A times 4?
4.
4A, right? So I get 4 equals 4A plus 2. What are the two steps to get A by itself?
1, 2.
Subtract 2.
Right.
What would I get?
1/2.
Everybody agree? 2 over 4, so 1/2. So A is 1/2. If I put 1/2 in for A, all I have to do is just expand that. So let's get a little practice with that. If I want to expand out y equals 1/2 times x minus 1 squared plus 2, what's the order in which I would simplify that? What would I do first? This is just regular PEMDAS now, right? I'm just simplifying. So I gotta do parentheses. Nothing in the parentheses I can do. But I could square those out. I could do exponents, right? So I could do x minus 1 squared. All that is just x minus 1 times x minus 1. If I FOIL those out, what do I get? X squared
1x
minus x. Okay, minus x minus x
plus 1.
plus 1. Okay, and if I combine the like terms, I just get it. Did everybody see where we get that? Right, this is just FOIL for FOIL, right? Yep.
How did you manage to make that like an outside?
Oh, that's a good question. I think it just skipped on there. That's better. There we go. Thank you. Okay, so this simplifies. I can combine those, right? So x squared minus, see, it keeps doing that, minus 2x plus 1. And really, that's just that stuff, isn't it? Okay, all we've done at that point is we've just expanded out the exponent. I still have a 1/2 out front and a plus 2 being added at the end. So what's next?
Distribute.
Distribute. So if I distribute the 1/2, what am I gonna get?
1/2 x minus 1x.
1/2 x squared, 1/2 times negative 2,
Minus x
minus 1x, good. And then
is 1/2.
last step,
Add 2.
yeah, combine like terms. So 2 over 1, if I multiply by 2 over 2, that's just 4 over 2, plus 1 over 2, 5 over 2. So I get 1/2 x squared minus x plus 5/2. Now it's in standard form. Okay, if you do that, you can do any of them. All right, what about, whoops, that's not what I want to do. What about this guy? I'm supposed to write this in general form. Quadratic function corresponding to the parabola that goes through those 3 points. Does it fit any of the special forms?
Yeah.
Yeah, it fits intercepts form or factored form, right? These have y coordinates of 0, so those are x-intercepts. So I know that p is 3, q is 9, right? And what is factored form or intercepts form?
X minus p.
Good, okay. So we'll plug in the values, and that's just going to give us y equals a times x minus 3 times x minus 9. To find a, yeah, the other point. Now it's got a 0 in it, but that's okay. It's the x coordinate that's 0. It's just an accident. It doesn't have to be that way. So when x is 0, y is 27, right? Okay, so if we plug in 0 for x and 27 for y, what do we get back here? So we get back 27 equals a times 0 minus 3 times 0 minus 9. What's 0 minus 3? What's 0 minus 9? What's negative 3 times negative 9?
27.
27. So I get 27 equals 27 times a. What's a? 1. So that makes this pretty simple then. If that's just a 1, we end up with our answer just equaling 1 times x minus 3 times x minus 9. So all I have to do is FOIL that out, combine like terms, and it's in general form, right? Okay, make sense? Okay, let's take a quick, I want to pull up one of the complete, well, I'll just make one up, one of the completing the square problems. So how about something like this? So write this in vertex form. Okay, what do I do? Okay, good. I write the f of x as a y. And I'm just going to isolate the x squared plus bx terms, right? Meaning I'll just get all the other stuff away from it, get on the other side. So we get y plus 3 equals x squared minus 11x. Okay? Now what? Okay, good. I have to add just the right number to both sides. So I can create a perfect square trinomial, right? We know the recipe. It's always half of that number squared. So plus negative 11 over 2 squared. What's that going to be on the other side as a fraction? 121 over 4. Okay. And then the reason I do that is because all this stuff just becomes the perfect square. What? Yep. Right? Whatever that number is, half of that number that I squared, that plus x squared is my perfect square every time. Right? And on the other side, well, we're just going to simplify that and get an answer. So what do we get over here? We get y plus 3 over 1 plus 121 over 4. Well, I need a common denominator of 4. So I'll just multiply this guy by 4 over 4. What do I get? 12 fourths plus 121 fourths is 133 fourths. Equals the quantity x minus 11 halves squared. So what's the only thing I have to do to put that into vertex form? Yeah, just subtract that term to the other side. So y equals x minus 11 halves squared minus 133 fourths. What's A? 1. What's H? 11 halves. Good. And what's K? Negative 133 fourths. Okay? Good. Okay. What was I doing with this? Oh, I know. Yeah. Graphing calculator stuff. Easy. This is a gimme. This one really is a gimme. If you have, it seems like in the honors class there have been a couple issues with the regression problem that we're going to do. And when we get to that one, so if you think you got it right, just show me and I'll get credit for it. And it's not very often, it's only happened a couple times, but just if it happens to you, let me know. Okay, this is from the graphing calculator test, where they want us to solve this guy, okay? We have some strategies. We have our graphing calculators available to us on this review and on this test. So one thing we could always do is just put that into standard form and use the quadratic formula, but we have our graphing calculator to do it for us, right? Does that make sense? I mean, that's going to work. You can use, I think I showed you how to use that Poly Smolт 2. If you want to use that, that's fine. If I showed you, great. If I didn't, it's not that big a deal. I'm going to show you next chapter. It's not really necessary on this. The other really valuable way to do this, but the other way I want you to know how to do these, you can use quadratic formula, but you can also, oops, you can also do this graphically. All you have to do is really simple. All we have to do here, why just keep doing that? There, okay. Yes, sir. Good. Good. Oh yeah, you betcha. You betcha. I got the. Okay, I'll get those two. Yep. Thanks. Okay, so all we have to do here is if we push everything to one side of the equal sign, this is a great trick for graphic calculators. Doesn't even matter which side. We don't even have to be particular about if we make the coefficient of x squared positive. For example, I could just take these terms and push them over to that side. What would I get? As long as I get it equal to 0, right? This is the other trick we know. Then whatever the expression is on the other side of the 0, if I graph that as y1, all I have to do is find the x-intercepts. Now the nice thing about this is it's always going to work. It doesn't matter what the function is. It could be quadratics this chapter, it could be polynomials next chapter, it could be radical equations after that, it could be anything. But as long as we get it equal to 0, it's always going to work to use that trick. So let's try that. So if I plug that in, negative x squared plus, I can make that 1/2 just a 0.5 is fine. 0.5x minus And then if I want to deal with a fraction, remember the little trick, we can always just put a fraction in parentheses and then just treat it like a number, right? So we could go minus the quantity 2 divided by 3. And there it is, right? All I have to do now is if I just go zoom 6, I want you to tell me where are the x-intercepts? There aren't any, okay? The x-intercepts always correspond to the real solutions. So are there any real solutions? No. What kind of solutions must we have for this? Imaginary, good. If they're in that, we're gonna talk more about that next unit, but if we don't have x-intercepts, that's the same thing as having imaginary zeros or imaginary solutions to that equation, right? Now, do you guys know how to find the x-intercepts if they are there? So for example, let me just tweak this function very slightly. Let me just tweak this. So we get like, how about plus 5? Let's graph that instead. Okay, so now I definitely have some x-intercepts. How would I find, yes, you can. How would I find, for example, the left x-intercept? Okay, I've got it. Where do I go on the calculator to ask it to find those? Remember? It's where I go for all the graphing stuff. Second calc, good. So second calc, and then which one do I want?
Intersect.
Nope, not intersect.
Value.
Zero.
Zero.
Remember that the zeros are the same thing as the x-intercepts, right? So we're going to choose 2. Now if I want to find the left one, anytime I want to find something on the calculator, it always asks me for a left boundary and a right boundary and a guess. And that means I just need to pick a point to the left of what I want to find, to the right of what I want to find, so I trap it between those 2 points. And then just a guess is any point in between is fine. I could either trace over like this until the little cursor gets to where I can see that it's, like right there for example. Isn't it, when you agree that's to the left of, I hit the left arrow until I was past the x-intercept, agreed? So I could hit enter, and look what it does. It sets up a little border on the left. It's only going to look to the right of that border, of that boundary. Now for the right boundary, I could trace over to the right, or I could even type in an x value, like 0 for example. 0 would work, wouldn't it? So if I type 0 and hit enter, it puts the other boundary at 0, and then for my guess, I could type like 1 or 2, or I could even just scoot over in between those 2 boundaries and hit enter, and look what it tells me. It tells me that the x-intercept is at -2, 0. The y-coordinate is 0, obviously, right? But that's the solution I was looking for. That's one of the solutions to that equation. How about that? The other one I could find by just repeating that process, just going back to second calc 0 and scooting over and surrounding the right x-intercept. Okay? Make sense? So you don't have to do that, but you can. It's not, actually. It's pretty quick. You can use the quadratic formula if you'd prefer, but that is a pretty easy way to do it. Okay? What else on this one? So, had that. Oh, no, there is one. I just don't think I made a copy of it. Okay, what about one of the regression ones? How about something like this? So what about one like that? These are the ones that it's possible one of these could mess up. I'm going to have to rewrite the code for these, but I don't know why. It's like 99% of the time it seems to work, but every once in a while it doesn't. I haven't figured out why yet. What do we do with these? Do you remember? If we're trying to fit this to general form on a graphing calculator, they give us 3 points. We can always do this, by the way, on a graphing calculator, as long as we have 3 points. Remember that 3 points defines, just like 2 points defines a single line, 3 points defines exactly one parabola. There aren't 2 of them. There's only one that could go through those 3 points. So what do I do? Just like if I were given 2 points, like if I were given those 2 points and I wanted to find the equation of the line through it, we know how to do it algebraically. I could also just do regression on a calculator and get me back to 1, right? Same thing here. How do I do regression? What screen do I have to go to?
Caps.
Not apps. Stat.
Go to max.
Stat. I go to stat, and then I'm only going to use these two menus, edit and calc, right? Stat, edit gets me to the spreadsheet, right, where I put in the x and y coordinates. Remember this? So I'd put in the x coordinates in L1, the y coordinates in L2, right? So for this one, I've got what, let me scoot over a little bit. I've got, for my x coordinates, 3, 4, and 6. And let's see, for the corresponding y coordinates, I just get 1, 4, -4. Agreed? Okay. So once I get those in there, what do? To have the calculator tell me the quadratic function that fits those. Yeah, I go stat, calc, but not 4 anymore.
Oh, dang.
Stat, calc,
5.
5 for quadratic regression. Okay? And if I hit quadratic regression, look what it does. It gives me back the answer. So the answer is -2.333333, so -2 1/3 x squared plus 19 1/3 x minus 36. And r squared tells me how good is the fit. As a decimal, it's 1, which means as a percent, it's 100%. 100% accurate. It's the exact function that fits those points. If I had tried to do linear regression, it would not have been exact. Right? I would have had a line, and it would have been, r squared would not have been 1, because those aren't collinear. Okay? I think covers it. Anything else you're having trouble with? Oh, you remember how to do the imaginary stuff?
Yeah.
Just put it into, like, because you're going to see something like that on the graphic calculator test and review. I'm going to give you a hard one you do not want to do manually. I'm going to give you a hard arithmetic problem involving complex numbers. All you have to do, though, is just put it into your calculator in complex mode, and it'll give you back the simplified complex answer. Everybody know, do we need to review one of those?
Yeah.
Okay, let's look at one of those.
I know.
So remember, here's the mode. If you go up and you hit mode, it's the one that says A plus BI. You need to be in that mode. If you're in that mode, inputting complex numbers is a snap. So I'll pull up a sample one. Okay, how about one like that? See, that would otherwise be kind of a tough problem, wouldn't it? Okay, now the thing is, my calculator is going to fail. Yours won't. Well, I don't know, this thing has a bug, but yours, and why don't you go do this with me? If you have your calculators handy, just go through this. So someone can tell me what the actual answer is. So to do this one, I'm just going to do the quantity 1 minus 2i. Whoops. Where's the I? It's behind, yeah, but it's behind the decimal point. So second decimal point gives me the I. You can see it back there. Divided by, and then I have to do this whole quotient, right? So I need parentheses. Is that us? Okay, fair enough. That's easy.